Dear friends, welcome to my channel. My name is Johannes. In this lecture session, I am going to discuss about analysis of simple structures such as method of joint, method of section, and frames and machines. So I think this is an important topic for all structures. Let us see learning objectives first. By the end of this chapter, you will be able to define an ideal truss and consider the attributes of simple trusses, and also you will analyze just plane and space trusses by the method of joints, and you will be able to simplify certain truss analysis by recognizing special loading and geometry conditions, and also analyze trusses by the method of sections and consider the characteristics of compound trusses, and again analyze structures containing multi-force members such as frames and machines. So these are the main learning objectives for this chapter. Now let us see the detail. So just as introduction, in chapter 3 above, we studied the equilibrium of a single rigid body or a system of connected members treated as a single rigid body. So we first drew a free body diagram of the body showing all external forces to the isolated body. Then we will apply just the equilibrium equations, force and moment. Then we can determine unknown reactions. So the unknown reactions may be just supported by different connections such as pin, roller, and fixed joint, and also something other also ball and socket, etc. So in this chapter, we focus on the determination of the forces internal to the structures. So that is just force of action and reaction between the connected members. So an engineering structure is any connected system of members built to support or transfer forces and to safely withstand the loads applied to it. So we have such connected members, then we will just consider such forces. So just an engineering structure of any connected system. So to determine forces internal to an engineering structure, we must dismember. We must dismember the structure and analyze separate free body diagrams of individual connected members or combination of members. Then we will define whether compressive or tension force. So this analysis requires careful application of Newton's third law. So which states that the action is accompanied by an equal and opposite reaction force. So we have equal force but opposite in direction, so action and reaction will be used. So we analyze the internal force acting in several types of structures such as truss, frames, machines, etc. So in this treatment, we consider only statically determinate structures which do not have more supporting constraints that are necessary to maintain an equilibrium configuration. Thus, as we have already seen, so we will use the equation of equilibrium, which are adequate just to determine all unknown reactions. Otherwise, we will have other technique. So let us see plane truss. So a framework composed of members joined to their ends to form rigid structure. Clear? Rigid structure is called a truss. So just we have truss. So bridges, roof truss, support, derricks, and other such as structures are common examples of trusses. So we have connected members. So structural members commonly used are, for example, I-beam. We have I-beam, channels, and again angle iron, bars, and special shapes which are fastened together as they are ends by welding. For example, we may use welding, and also riveted connections, or bolts and nuts and pins, large bolts and just pins such as J bolt and something anchor, etc. So when the members of the truss lie essentially in a single plane, the truss is called plane truss. So we have a single plane. It could be XY plane. So you can see this just you have cross beam. You may have different loads acting on this truss structure. So L represents the joint of loading, just the joint of loading. So you may have something load above that. So for bridges and similar structures, plain trusses are commonly utilized in pairs with one truss, just with one truss are simply placed on each side of the structure. So the combined weight of the roadway and vehicles is transferred to the longitudinal stringers. So the stringers are just connected members. We may just have some resistance with that. So to the cross beam. And finally, with weights of stringers and cross beams accounted for the upper joints of the two plain trusses, each for vertical sides of the structure. So you have such joints. These are bracing elements. So you may provide for bridge such type of structures. So let us see these plain trusses commonly used bridge truss. For example, Baltimore. This is Baltimore, and Pratt Howey Bridge again. You may have Warren and also K-truss. So we will see these structures in detail. And commonly used roof truss, you may have pink, such type of roof structure. You may have Pratt and also Howey again, and Warren roof truss also may be given. So the only thing is you just draw the overall free body diagram and calculate the external reaction, and then follow either joint method or section method we will follow. So let us see, this is just a roof truss, you can see. So just support is just acting on this one. So you may have such a bracing element. So simple truss, the basic element of plain truss is a triangle. So a triangle is the smallest plain truss. So 3 bars joined by pins at their ends. Just you have pins here, you have here pin, you have pin, you have pin. So these are the bars, 3 bars joined by the pins at their ends. Constitutes a rigid frame. So it will act as a rigid frame. And the term rigid is used to mean what? Non-collapsible structure. Non-collapsible structure. On the other hand, 4 or more bars pin jointed to form a polygon, as in case B. This is polygon, which is quadrilateral. So as many sides constitute non-rigid frame. We can make just a non-rigid frame, for example, such type of structure. So we can extend the structure by adding additional units of 2 interconnected members, such as DE, for example, DE, and again CE, we can just add, and or AF or DF, we can add. So these are additional structures for this quadrilateral. So which are pinned to 2 fixed joints. So in this way, the entire structure will remain what? Just rigid. So structures built for basic triangle in the manner described are known as simple truss. Otherwise, you may have just statically, just to prevent collapse, you may have statically indeterminate structures also may happen. So a statically indeterminate truss cannot be analyzed by the equation of equilibrium unknown. So you may just apply additional equation. So additional members or supports which are not necessary for maintaining the equilibrium configuration just are called redundant. So these are redundant extra. So simple truss, you can see, to design a truss, we must first determine the forces in various members and then select appropriate sizes and structural shapes to withstand the forces. So several assumptions are made in the force analysis just for a simple truss. First, we assume all members just to be 2 force member. Clear? All members to be 2 force member. A 2 force member is one in equilibrium under the action of 2 forces only. Under the action of 2 forces only. For example, you can see this is T or CC, compression or tension. So you may have such types of forces. So the 2 forces are applied at the ends of the member and are necessarily equal and opposite and also collinear. For equilibrium, it should be collinear and equal force but opposite in direction. So that's why we just apply action and reaction force, Newton's third law. So when we represent the equilibrium of a portion of two force member, the tension T or compression C, just compression C, acting on the cut section is the same for all sections. So you can see this one, C, compression, just towards the joint, or tension away from the joint. So I think let us see the methods of analyzing simple truss. We have the first method is method of joints. For example, you have such types of structure, which is truss. Then you can you can draw the free body diagram externally. Just you have system, just the system as a whole system. You have to draw just free body diagram. Then we find that in a simple truss, the total number of members is equal to 2 times the number of joints minus 3, where J is the total number of joints. We can check this one. If you have extra member, you can just assume zero force. And second, once you draw this external reaction, for example, this is beam, you may have force horizontal, but there is no any other horizontal force, so we can eliminate. And you have load, and then reaction 2. This is roller. Then second, analyze internally by making joint forces. We begin analyze with any joint where at least one no load exists, which is externally it should be no, and where not more than 2 unknown forces are present. So the solution may be started with a pin at the left end. For example, for this one, we can start at this one. Since this is R1 is just in the upward direction, so just the vertical force on this member AF should be in this direction. Clear? We can just put the correct direction. Then this is the horizontal. Then just the force will be towards the joint, which is compression. You can see compression. So if you have upward force, then you have just vertical component of the member should be in the downward direction. Then the horizontal will be to this direction. Then you have this one, the force should be in between. So AF will be compression. And then once you have this, if this is to this direction, clear? Then the horizontal component of this AB should be opposite to this one to maintain equilibrium. Then you can see this is AB, which is tension. Tension is away from the joint, and compression is towards the joint. So you can see the member which is under compression. Under compression, if you take out AF as a member, it should be like this, and T is like this. So to determine the member force AF and AB, just you simply use equilibrium equation. Sigma Fx equal to 0, sigma Fy equal to 0. So see, if you say sigma Fx equal to 0, then you have AB, then AB cos theta, then just if theta is given here, then you can find. So minus AF cos theta equal to 0. But from vertical equilibrium, you can find AF, clear? AF, because you have this no reaction. So similarly, joint F is to be analyzed, and then joint B follows. You see, you can go to joint B. Finally, joint E and C can be analyzed. Then finally, you arrive at D. Then equilibrium equation should be satisfied. Okay, as example, let us see. Compute the force in each member of the loaded cantilever truss by the method of joints. So step 1, as a solution, analyze the whole system externally. Determine external reaction at D and E, which is point D is this one, and point E is this one. So since point E is pinned joint, you have two forces. You can see AX and AY. Then this is tension cable. Then if you cut, then it will be like this, away from joint D. Then since it is perpendicular direction, then since this is equilateral triangle, you have this angle 60 degree, 60 degree, 60 degree, etc. You proceed like that. This is also 60 degree, 60 degree, then you can draw like this. Parallel line, this is 60 degree, this is also 60 degree. Then the remaining will be 30 degree. So like that, geometry will be used. That's why 30 degrees here, because this is 60 degree, 60 degree. Then this is also 60 degree. Just a construction line. So alternate interior angle. So since this is 90 degree, the remaining will be 30 degree. 30 degree. Clear? Then that's why you bring. So as your whole system, the boundary you draw external reaction, then these equations of equilibrium give summation of moment at E equal to 0. If you take moment at this point, you can determine T. 5 times T, which is perpendicular force, moment is force times perpendicular distance, then 5 times T. 5 is the distance times T, then minus 20 times 5. This is 5 distance, then it will be like this. So minus this is minus 5t minus 5t clockwise. This is plus 20 counterclockwise about E. Again, this is 30 times 10, 5 plus 5. Then T will be no 80 kilonewton. Then you can start now. Summation of force in X equal to 0. You can find EX, which is balancing this tension force. So EX will be this one. Again, summation of force in Y direction equal to this one. Then you can find EY. So once you find the external reaction, then joint by joint you can proceed. Then step 2, analyze the truss joints internally, which is determine internal force in each member. So you will draw free body diagram of each member force acting on each connecting joints. So write equilibrium equation. So you have this is downward. Then to balance this one, AB should be to the upward direction. Then you can just component you can take out upward. Then this should be to this direction. Then opposite to this horizontal, AC should be to this direction. So summation of force in Y direction equal to 0. Then just AB, which is AB sine theta, sine of 60 degree minus 30 equal to 0. Then AB will be tension, under tension. Then summation of force in X equal to 0. You have AC, which is to this direction, which is minus, then plus this one, which is sine cos, which is cos 60. Cos 60 is 0.5 times this one, AB. Then AC will be compression force. Then let's start from joint A. This is joint A. Then you can go to joint B. This is joint B. So I think we will have more examples on method of joints and method of sections. This is just to give you a highlight. Summation of force in Y equal to 0. Then you can find BC, which is compression, and summation of force in X equal to 0. You have BD and also BC and AB. Then finally, you can find BD, which is this magnitude. So once you have AB here, which is away from the joint, here also away from the joint, which is tension. Tension should be drawn, clear? If you go to the other joint, you have to make action and reaction force opposite to this direction, AB. This is AB. Okay, once you find this one, then you can go to, again, joint C. This is joint C. Then in joint C, again, you have these forces. So once you know BC and also BC and BD, then you can proceed like this. Then summation force in Y equal to 0, CD, you can find tension, then compression. Then finally, from joint E, just the results are just, you can see this equilibrium equation should be satisfied as a check. Summation of force in X should be equal to 0. Summation of force in Y again should be equal to 0. So this is as a check. As a check, it should be equal to 0 at the end. Okay, method of section. when analyzing plane trusses by the method of joints, we need only two of the three equilibrium equations because the procedures involve concurrent forces at each joint. Clear? Concurrent forces at each joint. So we can take advantage of the third order moment equation of equilibrium by selecting the intersection. Then you can draw free body diagram, etc. So this method, you can have advantage of just force elimination and also moment at a point you can cut. Just you should not cut more than 3. For example, you can have this. You have 1, 2, 3. So you can cut this one into 2. Then you can find moment, for example, at this point at E. If you take, you can find BC. Clear? You can find BC. And if you take moment at B, you can find A. You can find A because BE and BC will cancel out. Thus, it is not necessary. It is not necessary to proceed with the calculation of just from joint to joint, every joint, until the member in question has been reached. So, in choosing a section of the truss, we note that not more than 3 members whose forces are unknown should be cut. If the forces are not known, you should not cut more than 3, since there are only 3 available independent equilibrium equations, since we have 3. So from the relation we can find. So just you can have cut just for example this one, then moment. If you cancel 2 forces, then the third force can be calculated. So as example, you can see this is as example. Calculate the force in member DJ. DJ means this one, from here up to here. DJ of the whole roof truss. Illustrate, neglect any horizontal component of the force. So first, determine the reactions using the overall free body diagram. You can find AY and CY. Here, AY, for example, this one. Then you can cut, for example, section 1, which is just this one. CD, CJ, and KJ, you can cut. Then after cutting, you have such type. Then you can take moment at this point. If you take moment at this point, you can calculate CD. Clear? You can calculate CD. So CD can be computed. But let us see. If you take moment at this point, for example, you can cancel out JK because the line of action of the force will pass through A. So you can cancel G, JK, and CD will cancel out. Then CJ can be known. Let us see. Summation of moment at A is equal to 0. Then you can have this distance, which is CJ, which is perpendicular distance. You can have angle. First, you have to determine this angle using 6 panels at 4 meters, which means 1, 2, 3, 4, 5, 6, each 4 meter distance. 4 meter, 4 meter, it goes on like that. Then you have height again, total 6 meters, then you can find this angle. Then finally, by geometry, you can find the distance. Distance can be determined, this perpendicular distance, and also other distance can be computed. So 0.707 CJ times 12, because we have here 4, then you have, this is just 4 again. Then you can take a component, which is 0.745 degree. Then finally, cos of 45 will be this one, then times 12, which is 1, 2, 3, 4 CJ, then minus 10 clockwise moment at A for this section, for section 1. Then you can find compression, which is compression. CJ is compression, and some summation of moment at J. If you take at J again, you can find CD. Then CD will be compression. If you assume tension, for example, if you assume tension, then finally you can find just for CD, then you can reverse the direction. So CD will be compression. Then from the free body diagram of section 2, which is this one, again you take section 2. This is section 2 diagram, this one, with DE and DJ and KJ. So you can find just this diagram. From this diagram, from section 2, you can find, if you take moment at J, you can find DE. For example, DJ can be computed, but let us just take moment about G. About G. G means this one, about this point. You can extend, no problem. You can extend moment at this point, then DE will be cancelled out, clear? And this is also cancelled out. Then already you know CJ, then we will use CJ. Then finally, we can calculate DJ. So DJ will be 16.67 kilonewton tension. So frames in the machines, a structure is called frame or machine if at least one of its individual members is a multi-force member. So a multi-force member is nothing, just it is defined as one with 3 or more forces acting on it, or one with 2 or more forces and 1 more couples acting on it. So this is just you have multi-force member. So what is frames? Frames are structures which are designed to support applied loads, and are usually fixed in position. So machines are structures which contain moving parts, just mechanical moving parts, and are designed to transmit input forces or couples to the output forces or couples. So you may have, for example, power transmission mechanism, then these are just machines. So because frames and machines contain multi-force members, the forces in these members in general will not be in the direction of the members, clear? Because you can take power transmission, shaft and rotational object, then you may have this aspect. So the forces acting in each member of connected system are found by isolating the member with free body diagram and applying the equation of equilibrium. So the principle of action and reaction again must be carefully observed when we represent the forces of interaction on separate free body diagram. So if the structure contains more members or supports than are necessary to prevent collapse, then as in the case of truss, the problem is statically indeterminate. Clear? And the principle of equilibrium also necessary are not sufficient. So using equilibrium equation, you may not solve it. So they are not just sufficient for solution. Although many frames and machines are statically indeterminate, we will consider in this article only those which are statically determinate. So I think we will consider. So as example, you can see these frames and machines. The frame supports 400 kilogram load in the manner shown. This is a 400 kilogram. Then neglect the weights of the members, compare with the forces induced by the load, and compute the horizontal and vertical components of all forces acting in each member. So you will have member forces connected. Then first you have to draw overall free body diagram. Since you have pin joint, you have AY and AX, then 2 forces support here. Then in time frame, you have to determine external reaction. Since this is roller, you have just horizontal, which is normal force acting to this one. So since you have this weight, you can calculate weight mg. So if you multiply by gravity, you can find weight. So just you can have just 0.4 in kilonewton, you can just determine, then 3.91 kilonewton. So take moment at A, which is this one, more unknown reaction, then D can be calculated, which is dx. This is dx, horizontal force, will be 4.32. 4.32. Then you can have again, this is just important, which is distance. How do you get this distance? 3 plus 2, 5. 5 plus 0.5, 5.5. Clear? Perpendicular distance from here up to just joint A. Then summation of force in X equal to 0. Then you have AX minus dx. Clear? AX minus dx equal to 0. Then AX will be calculated. Summation of force EY equal to 0. Then AY minus this weight equal to 0. Then AY will be known. So once you calculate the external reaction, then dismember. Just the solution can be proceeded just by the use of moment at B. For example, you dismember it, then dismember, you have this member, which is B to this direction, to E direction, to the pulley, and the pulley again, you can dismember it. Then summation moment at B, for example, member BF, you take this member BF, then you have half of AX you have just you can find half of this one, then times 3, which is 3.92 times 5 again. You will take member BF. BF means, let me go back, BF, which is horizontal member. This member, you can take moment at this point. Clear? Moment at this point. Then half AX means action in reaction. Total AX you have, then you can have half of AX you have. Then you have again just AX means this one. Then you can see just half CX you can have. Then finally just this will be as a two force member. Then AX will be computed. This is AX, the horizontal component at point E. Summation of force EY again, you take BY, which is downward, just you can have negative, again negative, then plus 13.08 over 2. Then finally, you can have, this is AX, then you have EY, then BY will be computed, half of AX, which means this vertical force. Then finally, you can calculate BY. Then summation of force in X equal to 0. Then you have BX to this direction. Then plus this one. Then minus 13.08. Then finally, BX can be computed. So positive numerical values of the unknown mean that we assumed their directions correctly on the free body diagrams. So the value of Cx equal to Ax, which is 13.08 kilonewton, just obtained by inspection of the free body diagram of C. Then you can enter into the diagram for AD. For A to D, you can enter action into reaction. Then this Px will be used. Then summation moment at C, you can take at C. Then since you know By and Bx, you can calculate. Then finally, solution will be, you can find the solution here. Solution will be, you can find the overall free body diagram. So since all forces acting on it have already been computed, so the equation will give you this one. Okay, thank you very much. Okay, thanks for watching this video. If you have any question or doubt regarding this topic, please write down in the comment section below. I will reply on it. Thanks again.